Okay, cool. So I guess we are back, and let me give me a second. Okay, so my screen is visible, right? A quick yes.
Yes,
Okay.
yes,
So
yeah,
what we'll be learning today is a very one of the most again powerful data structure, which is tries. Okay. Now a little bit of theory around tries is like okay. So we kind of categorize into two tries. Okay. One being string. Okay. One being string try, one being bit try. Okay, and I'll explain you what are these and how do we solve problems on that. Okay, so generally, in order to uh, kind of store efficiently, in order to store a string efficiently or retrieve a string efficiently, or do a little any kind of prefix match or make a dictionary, in all this kind of applications this try comes into picture. Okay, so generally like we have a string, right? And you know that string takes a good amount of memory to store, right? In our memory, but try kind of manipulates in a way where we can store the string in a very good fashion, and even when if we need to manipulate or do some calculation, tries are actually really a good way. Okay, so whenever a string coming in, you might think of a try problem. Okay, and I will tell you what bit try is, but yeah, let's focus on string try first. Okay, now, so let's say we have some words with us. Okay, we have some words. Say the words are a something like this, maybe aba, okay, bad, bat, c cam, something like this. Okay, so say we have these words available with us. Okay, and we kind of need to manage these words. Manage in the sense we need to store these words. Okay, and after storing these words, maybe we will be given some problem and we need to think of how to solve based on this. Okay, so how is try is again a tree data structure only. Okay, it's almost like a tree. So you remember in segment tree how we manipulated the node structure? It's also similar to that what we will keep in our node. Okay, so
okay,
in try we start with a very we start with a starting node, which is nothing but which is a root node. Okay, now what we do is let's start processing each of the strings. Okay, so can you see the first word which we have is a. Okay, so what we do, we start every time with root node. We start every time with root node, and in root node what we will have is, from here we will see whether a link of a is present or not. Do you see anything of edge a? We don't have right now because it's an empty tree. So what we do, we create an edge, we create a node which is nothing but a. Okay, now the next character which is again a. Now you are at this level. Okay, you are at this position. Can you see any edge of a here?
no,
No. So
no,
we what we do, we just go ahead and create a. Okay, now again the third letter is also a. Since I don't see anything, just go ahead and store that node. Okay, do you see we have processed a? We did process a, right? So remember this, as soon as you complete finishing
yes,
a node, okay, you mark this as done or maybe something true. So what this will tell is that this this node this node is the end of one word. Okay, since we have processed a, this node is the end of one word. Okay, is this clear?
yeah, yes, bro.
Okay, chalo. What's the next word? A. Okay, a. So again, from where we will start, we'll always start from the root only. Okay, so what's the first character? The first character is a. Do you see there is already a link a from here?
Yeah,
Yeah, so we will go here only again. Now what's the next character?
B,
B. But do you see any link of B?
No.
no,
So please go ahead and create it. चलो ठीक है. From B, do you see any link of A again? No.
no,
This is my node. Okay, and Did we finish the word ABA? Yes. So
Yes.
please mark that's true. That means this is the end of the string ABA. Okay. Now, what's my next word? Next word is BAD. Okay. So let's start from here. Do you see any link of B? No.
No.
So just go ahead, and I'm writing now little fast because you understood the
Yeah.
things. Okay. So BAD,
D.
which is true again, something. Next we have, maybe we will use a four length now. Okay, bats. Okay, so it's now you see B is already there, A is already there, T is not there. So T. Next S, and finally we have cam. Okay, so we don't see any C, we don't see any A, and finally this marks the end of your inserting of all the words into a trie data structure. Okay, so is the process clear? Whatever we have done.
Yes. Yes.
Yeah.
Okay, so now let's say you have all the strings ready with you. You have created everything. Okay, now someone just comes up and they ask you that, uh, okay, bro, can you tell me whether BAD exists or not? Okay, BAD exists or not. So what will you do? Okay, so before, let's take a step back and maybe we can discuss of something else. Okay, so given some set of strings, okay, check whether a string is available or not. What will you do in that case? Given some set of strings, given a word, you should check whether that exists or not. What will you do in that case?
With the try or without try?
Yeah, I mean without try, because we are taking a step back, right?
Okay. So basically, we can store them in
Mhm.
set or hash set.
Yes. So one of the better way is storing in a set, right?
Yeah.
But do you remember I mentioned you? So what happens when see, when it's a number, it's very easy. But when
Mm.
it's a string, internally it has to manipulate something, right? It has to calculate a hash function. Right?
Yes. Yes. Correct.
So for all the strings, it needs to calculate a hash function, and for given a string, it again needs to calculate. I mean, okay, obviously it's okay, but again, it has some complexity associated, right? So this problem is obviously solved using set. But now I just ask you that given a string, okay, tell whether there is any word which is a prefix of the word. Let's say I tell you I am giving you the word AB. Is
Mm.
there any word which has a prefix of AB?
Yeah.
Yeah. In this case, we know that
ABA.
this is ABA is the word. But
Hmm.
Mm.
now what's the problem? The problem is, in the worst case you have to iterate on all the words.
Correct.
Correct. In the worst case you have to iterate on all the words. So this makes our problem hard, right?
Mm.
Now again, you remember, right? So in order to make the things complicated, what we do, we just tell you that we will give you q queries, and which will be nothing but 10 power 5 queries, and for each query I
Mm.
will give you a word. So if you iterate on each of the string, then it's done. We are gone there
Mm.
itself, right? Now if you see how try comes into picture is, let's say we have AB, right? So what we will do is we will start from the root node itself. What's my first letter? Which is
A.
A. Do we have A? Yes. Do we have B? From A, we see there is a B. And can you see, we can tell in just length of this word whether it exists or not.
Yeah.
So instead of going on all the strings, we just iterated on this string itself and we made sure that our string exists or not as a prefix. So what was the worst case time complexity? Can anyone tell me this?
Login.
No, no, this one. This the brute force one.
Brute force.
Yeah. Maybe Manan is here, right? I believe.
No, no, no.
Oh, he's not here.
Q into N. Q into N.
Q into N. Wrong. These are strings. Remember, I told you something about strings. why it is not q into n. Okay,
Mm.
so I tell you that I will give you q queries.
Correct.
The number of words are n. Everything is good. But
Mm.
what about matching? We have matching also, right?
Mm.
So let's say average word length. Okay, I mean
Mm.
some words might be small, some words might be large, right? So average length, average length of word. Now is it fine? Did you understand why
Yes.
there is this
Mm.
additional factor which came into picture? Because it's not number. You have to travel the string also, right, in order to check.
Yeah.
Yeah.
So q into n into average length of the word. Okay. Now this is the brute force time complexity. Now what about your optimal time complexity using tries? Can you see we only traveled a length of word which is given in the query? Correct. So q
Yeah.
into average length. Average length means
Yes.
average length of the query word, and this will always pass. Okay, in your questions. Cool.
Okay.
So did you understand what is this?
Yeah.
Okay.
Yeah. Yeah.
Now, like
Yes, bro.
there can be many things. Okay, I mean we will solve it. But can you see this is a tree data structure? If it is a tree, can we do a DFS on this?
Yes.
We can do a DFS. If we do a DFS, we can solve many problems of this. Okay, let me give you an example. Let me ask you that. Okay, uh, can you tell me uh, top two lexico? So everyone knows this word, right? Lexicographical,
Yeah.
which is nothing but dictionary order. Top
Mm.
two lexicographical words which starts with A. Top two lexicographical words starts with A. That means which should start with A. So can I say the answer will be A and ABA?
Correct.
Correct. So now let's say there is one more. There is one more which is A B. Let's say D. Okay, A B D. Now the answer will still be same, A and ABA. Okay, can you see that if we do a DFS, we will go here and here first. In a DFS, we will always go to, I mean, left, in the sense like if we can write a recursion of DFS, and we make sure that we always process in the lexicographical order, we can kind of make this problem solved, right? Okay, we will take this question today, but anyway, I'm just telling you. Okay, so shall we start with creating try now, and let's see how the code works.
Yeah.
Yes, bro.
Shall
By the way, Manan has joined the session.
Hey, hi Manan.
Hi.
What man? What takes you so long?
Yeah, I come from outside.
Sorry,
मैं बाहर गया था इसलिए लेट हो गया.
what your friend is not joining these days? Session. What's happening?
Don't know.
So we are looking into try, okay, and like the introduction part is done, so I am kind of telling the code
Yeah.
part. Okay, so just see this diagram. This is a try. Okay, that we have some words and we need to insert them in some manner. Okay, so we will just go like this, that let's say I have to insert a. Okay, so I will create a link a a. Okay, so this again, it's almost like a tree only. Okay, nothing special, but yeah, it has some extra features. Okay, now so let's
Yeah.
start with our stuff. Public class. Okay, let's not that. I don't know, but there is some.
लोड हो रहा है वो अभी भी भाई.
Okay, so guys, let's start with our. So do you remember it's nothing but a node only in this how we create a segment tree ka node. Similarly, this is also a node. Okay, so class node. Now what will store in a node? Okay,
Edge.
yeah, give me a second. One second.
Okay.
हाँ भाई, ये भाई class node की बात। अच्छा भाई ठीक है चल हाँ, बोल yeah. So Sam, you are telling about edges, right? That's correct. Okay, so
Hmm.
we need edges also, right? So can you see edge with a node? Correct. There
Yeah.
is an edge with a node. So there are multiple ways to create a structure. What we will do is we will follow the natural process, which is nothing but map of character comma node child map. Does this make sense? Character is the character, and each character has a node associated, right?
Okay.
So that's the reason we will create this. So Manan and Sahas, did you understand this map?
Yeah, yeah, got it, bro.
Okay. And Manan, did you understand what's that?
Yeah.
Okay. And we need a boolean. Why boolean? Boolean will tell that whether the string is done or not. Okay. Is okay. Now we'll create a constructor. This constructor will mark this dot child map equals to okay. So we created a hash map on this, and obviously this dot isEnt will be false. Cool. So is the node structure clear for everyone? Sam,
Yeah,
Sahas?
yeah.
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 Yeah. Clear.
Okay, chalo. Okay. Now this is your node structure. Okay. Now we will create one more utility class, which is try. This try is responsible for adding the words, searching the words, whatever. Okay. Now initially, do you remember we always start from root node, right? So we will have a root ready with us. Root. Okay. And as soon as we instantiate this try class, we will have something as this ready. Okay, so always a root will be available, remember this. Okay, always a root, that is this node will always be available. So we start with having a root node. Now what are the functions we need to support? We need to support addition
Create.
of, yeah, we need to support addition of or the insertion of the words, right?
Hmm.
So public void insert string word. Cool. Okay, so we have to insert the words in a try data structure. Okay, now remember what I just told you is we always start from the root node, right? So
Hmm.
root current node is equals to root, that is we start from the current node. Now for int I equals to 0 and not 0. So what we need to do now, we need to travel through all the characters of the word, right? So
Hmm.
for character c in word dot to char array. So I am iterating on each of the characters which are there in the word a b a like that. First thing to check, if so, do you remember what happens? Like we need to have that character, right? If there is if the character link is not available, what we do? We create it. Right? So if current node dot child map dot contains key c, that is if it does not contain, what I need to do? current node dot child map dot put. Can I just keep here as? Does this
Okay.
if condition make sense to everyone?
Yes.
Yes.
Okay. So
Yes.
we have a node here. Okay. Let's say we are getting edge A. Okay. This is for the first time. The first time the tree will be empty. Whenever we have the character A, there is no edge here. So what we do, we create an edge A and we create a node. Cool. And this is what we have
Yeah.
done in this code. So are you clear on this if condition part?
Yes.
Okay. So once done, we need to go to that node itself, right? So current node equals to current node dot child map dot clear. Is this line okay now? Or do you have any confusion on this? See, initially current node was here, right? As soon as you inserted A into map, you need to go here, no? For the insertion of the next characters.
Mhm.
Yeah.
So that's the reason current node will become go to your child node.
Yeah. Okay.
Okay, make sense?
Yeah.
Okay. And once this for loop is processed, that means we are done with the word. If we are done with the word, can I say this?
Yes.
And this is the only code which you need to write for the insertion of the word. I mean, there is nothing else, right? What we did, iterated. If there is no node, keep it. Go there, fill it. Okay. Now, what we will write now? We will write the another
Search.
question was search. Public void search prefix. Okay. Search prefix. String of word. So again, same from where we will start. Always we will start
Root.
from root node. Now for character C in word dot vocab array. Okay. If kernode dot child map in my child map, if I don't have my current character, can I immediately return false from here?
Yes.
Right? I mean, this should be a boolean, of course. Okay. Okay. Otherwise, if if there is a link, if I can go to my child, why don't you go there? You just go over there, and if this for loop is processed, can I say
True. Yes.
Khadam, question done. In physics is done. Okay. And if you need to search whether the entire word is there or not, okay, public boolean, same thing. Check word exists. Okay, string word. So nothing. What we'll do, we'll take this same thing here now. So we need to check whether this word exists or not, right? So what should I write now? I am at the last. I mean, I have already done. So shall I return true here?
We should check current node marker as true or false. That one.
Very nice. Clear?
Yeah.
I mean, you can write this also. That means if it is a true, that means we are done with that word. Because you remember always whenever we processed a word, we marked it as true. So at the last stage, if we have it as true, it will give you true. Otherwise, it is false. That's it. So is the three utility methods clear to everyone?
Yes, bro.
Yeah.
Understood.
Manan, did you understand this?
I was not there during question, so I'll have to see recording.
No, the question was you have inserted few words and you were searching a prefix. Okay. In the
Okay.
given words, whether a prefix exists or not.
Okay.
Prefix means what?
Brief word.
Yeah, the prefix part, right? So
Hmm.
we have this structure ready. If I ask you, Manan, do you like, is there any word as BACK? So you see that, okay, we go to B, we have A, but there is no C. There is no C over here, right? We have D, we have T,
Hmm.
but we don't have C. So that's the
See.
reason. That's the reason we will return as false. So this is
Okay.
nothing but the prefix part searching. What about the full word search? That is whether there is a word in the try or not. Let's say I give you the word A. You see A, A, and it is true. True means that this node marks the end of this word. And as soon as you see that there is this value as true, we are returning that. That is and.
Hmm.
So if you see, whenever we inserted the word, I am making it as true as soon as the word got finished,
Yeah.
as soon as it processed. Okay. Sure.
Understood.
So shall we
Bro,
write it? Yeah.
string itself is also a prefix for it, like a complete string.
Yes, bro. We can say
Okay.
that.
Suffix also same, or is there any?
Yes, correct. Suffix also same. Yeah, good
Okay.
question, Sam. So one thing is prefix and suffix is that. So there is one more terminology which is proper prefix or proper suffix, I believe. Okay.
Okay.
Which we will see tomorrow's class. Okay, which will come in strings data structure. Now, so what we need? So we need to insert some words, right? So
Hmm.
नहीं first तो try catch बना देंगे. Int n. Okay, so these many words we will insert while n minus 1 is greater than 0. String s equals to, okay, so what we need a try ka object, right? Try equals to need try, and finally once if we have the try object, try dot insert s. Clear? Let me write
Yes.
it as word itself. So we have inserted all of them. Okay, now we need queries, right? Int query. Okay, so what we will do, we will take same type 1 and type 2. Type 1 means search prefix, type 2 means check word exist. Okay, int type, if type equals to 1, okay, system dot out dot println is prefix. So obviously we need to take a word in order to search. So is prefix, uh, shall we just write true or false, or do you want me to write some statements?
True or false is enough.
Enough, right? Yeah, I mean, we are DSA people, so those time has been gone now. Okay, so t dot, sorry, try dot check, what's that method? Search prefix. Okay, else try dot. Clear? I mean,
Yes.
okay, so shall we run and see what's, whether we are getting the perfect answer or not?
Yes.
Okay, so shall we take the same question? I mean, this words itself, or do you have some other words in your mind?
We can try this.
Okay, so there are five words, right? There are five words. What's the first word?
Triple A,
A,
Uh-huh.
ABA,
Okay.
BAD, BAT, CAM.
Okay, so we have inserted five words. Now we need query. So how many queries? Five queries or four queries? Let's say
Five.
five queries. Five queries, yeah. So which one do we need? Prefix or word exist?
Prefix.
Okay. And what's the word?
BAT.
AB. Hmm.
Sorry,
AT.
BAT. True. So did we see that bats? So that's the
Hmm.
thing we got to. Let's take a negative, I mean, an anti-test case.
CB.
C.
B.
So false because we don't have anything as CBA as a prefix. Okay. Let's go for second kind of query. Okay. Yeah. Manan, do you like to try and do you want to give any word in order to check?
Which will be the card?
Any word?
If you give same word, you should get
Okay.
false.
Is there any word as Manan in our
No,
structure? No. That's the
no,
reason we got false. Okay.
false.
Let's say I want, did we get true?
Yeah,
Because bad
Yeah.
is here. Okay.
yeah.
And
Bhaiya,
yeah.
one A1.
Okay.
Try CAM.
CA.
M. Okay. So it will check over whole length also, right?
Yes.
Whole word.
Yes. It will check the entire length. Okay. Clear?
Yes.
Yeah.
So it was easy only, right, for you guys now because you have seen good amount of code. So
Yes.
it shouldn't be much harder now, right? Chalo. So these are the problems. Okay. Now let's take couple of problems and then we'll move to bit try. And I have a question for you guys here. Longest, and this came as the fourth question in one of the contest. So we'll try to solve this. Okay. Okay. So yeah, what I was telling you is okay. Let's take this question itself. That given given set of words, okay, given set of words, okay, some array of words or some list of words to you, okay, what you need to tell is, okay, you will be given for each query, you will be given a word w, okay, for each query you will be given a word w. You need to tell, okay, w comma k, this k is an integer, okay, you have to tell k, same question, k lexicographically, k lexicographical words which has a prefix of w, okay, k lexicographical words which has a prefix of w. Is the question clear or shall we go to a diagram and
Yeah, understood.
see? Okay, others?
Yeah, got it.
Manan, did you understand?
So input will be
Yeah.
uh,
So you will be given initially some words, okay, some set of words to you, and after that I will give you each query, okay. For
yeah,
each query I will give you two things. One is a w, which is a string, which is a word, and there will be one integer which is k.
yeah,
What you need to print is you need to print k lexicographical words which has,
with prefix.
yeah, k lexicographical words which has a prefix of w,
Hmm.
okay. Now in the same question, if I give you a comma 2 or maybe b comma, yeah, b comma 2, then what should be the answer, guys? Can someone tell me? B comma w or b comma 2, then what should be the answer?
BAD
Huh? Okay. And
BCT.
no, no, no.
BAT.
BATS,
Sorry. Yeah, sorry.
BATS. Yeah.
right? So
Yeah.
it cannot be BAT because there is no true here, right? I mean, true means which will say that it's the end, right? So BATS is the I mean, it is marking it. It is marked as true. That means BATS is the word, not BAT. So for this, for B comma 2, the answer is nothing but BAD and BATS. Okay. So now is it clear, Manan? Sorry.
Yeah, clear now.
Okay. So we have these words and we need to find k lexicographical words. Okay. And let's say if there are less than k words, print how many of them are available. Let's say if I tell you B comma 5, so you can only print BAD, BATS and BC, right? You cannot
Mm.
print more than that. So in that case, you need to print only those three words. Okay. So I hope the question is clear. So
Yes.
try to think
Yeah.
for a minute. Okay. What can we do?
Like something like using priority queue.
Give me a minute, Sam. I will come. Okay.
Okay.
But not a priority key. Okay, because k can be larger.
Okay.
Instead of hash map, should we use tree map?
Yep. Instead of hash map, can we use?
Tree map.
So in the structure you're saying.
Yeah, yeah.
But this structure is what? This structure is not. See, this structure is related to the links, right? SAS, A, B, C. Even if you create a tree map also, how will you know? How will you find k lexicographical words?
So my intention is like we can go to the prefix match node.
Okay.
So consider the example.
Mm-hmm.
Uh,
So,
so you have asked b comma 2, right?
yeah.
So we can go till b node
Okay.
and iterate all elements in the map.
Nice. Correct. So,
So until we reach the true
mm-hmm.
and k minus minus. I mean we can decrement the k value.
Okay.
It should be greater than zero.
Perfect.
Like we can have a check there.
Perfect. Perfect. Yeah, that works. Okay. And yeah, the tree map, whatever you're saying, that also works. But can we like okay, instead of having a tree map itself, SAS, can we create a hash map and solve this problem? Because tree map has this additional log and time, right? So we don't
Mm-hmm.
want that. Okay.
But
So
how can we make sure it's a lexicographically?
think you have the answer ready. So can we write a for loop from A to Z?
Yeah, I thought of it, but it will be a
26 additional.
26. Yeah, yeah.
Yeah. So like there is this I mean, if the it depends, okay. If the characters are more, in this case, it's only A to Z, so it's log of
Mm,
26. But there
mm,
also, okay, I mean, anything makes sense. But yeah, the intuition is correct, okay. If you write tree map also, it will give you the right answer. If you just write this also, the only thing is I don't want to come up with an additional extra space of that login. That's the reason.
okay.
Okay. So guys, did you guys understand what he just said now? Sam and Manan. So what he said, if we have b comma 2, okay, so first we will obviously go to b, right? That's for sure. And from here we will simply go to left parts. That's it. Okay, left parts means जहाँ जहाँ तुम लोग को available है, go and explore. That's it. So maybe we should write code and you guys will understand much. So at least is 50% clear whatever he said?
Yeah.
Sam? Oh,
Yeah, I was talking on mute. Sorry.
okay. So did you
Yeah,
understand?
got it. Like anyway, tree map will be sorted, right? That's the reason. Just iterating from there.
Yeah.
Yeah.
Okay. What about Manan? Did you understand what he just said?
Yeah.
Sure, right?
मैं
Or
भी वही सोच I was thinking जैसे सास was telling but मैं बोल नहीं पा रहा था उसका.
okay, no worries. Chalo, shall we write it then? Yeah. So, I'm keeping hash map only. Okay, I will just iterate on one to A to Z. Okay, or do you want me to change to tree map? Nothing matters. I mean, both of them works. Sas,
We
you
should
say.
go with hash map.
Yeah.
ठीक है. तो पहले तो भाई there are these words for sure. So, I mean, this structure is not going to change, right? This structure is not going to change. So what we will do is public void, not void, uh, top k like strings. Okay, so string word int k. This is what we need to solve. Okay, that is top k lexicographical strings given a word and k, right? So quickly let's write this method. Okay, so each time we will be given string word, which is this, and int k, and what we need, list of string answer equals to try dot. Okay,
Mm,
quickly we will just for string x answer system dot out dot print, and we will have a space. Okay, and
mm.
these are just the utility stuff. Okay, so as usual what we will do, we will start with
Root node.
root node. Okay, next we have to make sure that everything is present there itself. Okay, so for uh, in order to like have an answer ready, we will make an answer
Mm,
new array list. Okay, for character c in word dot to char array, I'm just copy pasting few of them. So in this case, can I just return answer from here?
yes, yes.
That is, if the character does not exist, please return an empty list.
Mm,
Okay, otherwise now we are here. That is, current node is the end of word. Make sense? That is,
yes.
b means we reached here. Okay, now what we need to do, we need to do a DFS, right?
Mm,
So क्या करेंगे DFS में? We will go with current node. Okay,
Current node.
we will pass word.
Okay.
Why word?
Word.
Because I need to append everything to that. Okay, word
Okay.
comma yes k, and maybe answer, because we need to
Answer.
store everything, right? And once we are done, okay, Next, private void DFS node current node string word. What else? Int left. So left is how much, I mean, kitna baki hai, how much is remaining. Okay.
Hmm.
And finally, so at this instant, first thing we will write the base case. So can anyone tell the base case?
If k left equals to 0, return answer.
I mean, it's a void, right? So
Okay, okay.
okay. Now otherwise, I mean, if curve node dot isn't,
Return answer.
eh,
हाँ
answer
sorry
it, answer dot add
add हाँ
कर लेंगे ना word.
but
Yeah.
Okay. So here I am changing a bit, SAS. Okay. So answer dot twice, because if it is adding, okay, I just want to make sure that as soon as it crosses the limit, we are just returning. Okay.
Okay, okay.
Okay. Now what we'll do? For loop char c equals to a, c less than or equals to z, c plus plus. Okay. 26 iteration. Obviously, this can be improved via tree map, but again, that has that additional complexity. Okay. So there is this trade-off anyway. So what we will do, if current node dot child map dot contains e, अगर है तो ही, if we have it, then only we need to go there, right?
Hmm.
So
DFS
DFS of
C
uh, what yeah, tell me.
current node with C
Kernode dot child map dot get c. Okay, इसमें word
word
plus और plus c.
Yes.
लेफ्ट का क्या करेंगे, लेफ्ट का shall we keep,
-1 ना नहीं
नहीं, because I am checking like this time, so left is always constant. Okay.
Hmm.
Is there anything wrong we have done here? What do you think? Just to be little more fast, I can add, do it here also. Okay. Yeah. So understood what we have done. A to Z. If it has, call a DFS. Make sense?
Yeah.
SAS?
Yeah, yes, bro.
Sam?
Yeah, got it.
Okay. Manan, it's fine, right?
हाँ yeah
So I believe this should be it. And let's see. I mean, not sure. So how many words we need to insert? 5 words. A, B,
BAD.
query. How many query? Is 3 enough or 4? What? 4 ले लेते हैं. Okay. Sam, tell the word. So let's check B comma 2
B.
only first. Okay.
Yeah.
आ गया?
Yes.
Okay. So let's see A comma 1. Okay. I guess we should have taken some better inputs. But A comma 1. Oh, you got 2. How is it possible? So we have a one pass करेंगे इधर. Okay, so A will go answer dot size greater than def. Okay,
Arya.
so where do you think we have made a mistake? A comma 1.
Greater than or equals to.
Okay. Greater than or equals. Yep. Seems correct. Yep. So if we even inserted that many words also we need to return, right? Why to go for greater, right? I mean, what is this? What is the meaning of this? We have already inserted this many, right? So if we just write greater than, that means we have crossed one more. But if we just write greater than or equals to, that means we have already inserted this many words. Okay. Yeah, Sam, perfect. Okay. And let's say we have B2. What's this? Okay, B is only one. B is only one this time. See,
Yes.
C1.
Yeah.
Okay. Now let's say C4 cam cats. Okay. C1 cam. Clear? So
Yeah.
are we getting the perfect
Yeah.
keywords?
Yes.
Okay. So yeah, we have some time. So is this code I mean, you guys understood, right? What we have.
Yes.
I mean, it's not very hard code, right? Like,
Mm.
but if you see, like, there was some question and we were able to boil it down to a very small level of code with normal DFS because we are understanding what DFS is. Okay.
Bro, like there may be a case like, and now we are knowing A to Z, small a to small z.
Mhm.
Like there may be a case where we don't know what are the characters will be
Yeah.
present in that.
Then iterate on the map with tree map.
Mm-hmm. Or
Because
like, can we store the childrens of that in the priority queue and get the smallest one and looping in that way?
see, if you are telling about smallest, okay, so
Mm.
smallest comes only with A to Z or something like this. Okay, if the interviewer tells you to go with what ASCII number, okay, so
Okay.
there is this 256 or some ASCII numbers, right? Probably.
Yes. Yes.
So you can write a for loop of that, probably.
Okay. 0 to 256.
Yes.
Mm-hmm.
Okay, and you can make the things done.
Okay. Okay.
Yeah, because now we are in a stage where we have to think of different ways, right? Now
Yeah.
we are on the end of, and yeah, these are the questions which should pop up in your mind. And I don't know if you know this or not, Google gives you this bonus points when you ask different questions to them. But it's up to them that whether this question is a valid or not.
Okay.
Yeah, but yeah, if you ask proper questions, they actually give you some bonus points. Anyway,
Like in the interview, you're telling.
yeah,
Mm-hmm.
do you think on your salary?
No. No. Like
Yeah.
we can. I did not think that in the interview we can ask questions like that.
Hey, this is a rule, man. This is a
Uh,
very important rule. Oh,
okay.
then you should attend the mock interview for sure. Okay.
Like technical questions or about the company.
No, no, no. See, what he just asked that uh, can we have characters different than A to Z something, right? So
Hmm.
for now, this code only works for A to Z. But what
Correct.
about if we add some dollar something something? Okay. So
Hmm.
I don't know like whether tree map will store them in sense of ASCII or not. Okay, it should
Hmm.
store in sense of ASCII only. But again,
Hmm.
if we can kind of write okay 0 to 256 or whatever, then
Hmm.
it makes our job done, right?
Hmm.
But yeah, so the level of questions or the way you're approaching to your problem with different constraints matter.
Hmm.
So if you ask a different question, and if the interviewer thinks that yeah, this makes a valid point, then there is this additional bonus. I mean, bonus in the sense they will consider, okay, he's able to think of.
संपत भाई गूगल ट्राई करो.
Okay, chalo. So shall we move to next question then?
Yes, yes.
Manan, ready?
Yeah.
Chalo. Given a string, find the count of unique substrings. Okay, given a string, find the, okay, let's take a small example. This is a little larger. Yeah, find out the number of unique substrings. So how many unique substrings are there for this? A, 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 B, A, B, B. So the output should be 6. Okay. So given a string, okay, first tell me how many substrings, little quick. Given a string of length n, how many substrings?
n into n plus 1 by 2.
Yeah, you remember that formula, n plus 1 choose 2, a diagram.
Yeah, yeah.
Yeah.
Yes, yes.
Okay. So for this string, there are how many? 5, I guess. 5, no, 6. There are 6 substrings which are unique, right? So you should count 6. I mean, you should print 6. So how will you do this? Think of in a try itself. I mean, since we are reading try, the answer should come from try. Did anyone want to know the length of the string? No one asked me that. What's the length of the string? Okay.
5,000.
Yeah. Okay. At least brute force. Manan, brute force कर लेंगे. Manan.
Those will be generate all strings.
His voice is a bit low, man. Can you come near to mic?
1 minute. Hello.
Yeah. Brute force.
Yeah, generate all substrings. Where
or unique.
check.
Okay. So set में लगा दिया तो हो गए.
Correct.
So if we can keep a set and add all the substrings, then also we are done, right?
Yeah, correct.
But there is this problem. What's the problem? I mean, you remember again, there is this, you're not adding an integer to a hash set. You're adding a string to a hash set. So it has this additional component. Okay. So yeah, I mean, brute force, we guys can do.
Yes.
Yeah.
Doing in an optimal way. Think, how can we do it? Think in a try structure only. Okay, let's try to boil it down a bit. So if n is less than or equals to 5000, can I write an n square solution?
Yes.
N square to ho
Yes.
jayega, right? So the problem with hash set or whatever is that n into this some additional cost of adding and checking, right? Which makes the limit go little beyond. Okay, so if they fix a tight time that okay you need to complete in 5 into 10 power 7 only, so then there is this problem. Okay, but if we can make it in n square, can I say we are good? Because 5000 into 5000 is how much? 25 into 10 power 6, and 25 into 10 power 6 we are in a bound, right?
Yeah.
Okay, so n square तो लिख सकते हैं. Okay, n square तो we can write. So let's start.
Like
Yeah,
in that case, generating subsequences and storing that as a tree data structure.
not subsequences, no substrings.
Sorry, substrings, generating all substrings.
Yeah, and adding into set and checking.
Yes,
Yeah, that's correct.
not set like in the try itself or
Yes, correct. So do you see this word AAAB? So let's start with first substring. Okay, we have this word AAAB, right? So the first word is,
yeah.
as soon as you add, what is the meaning of this? The meaning is, can I say there is a new addition?
Yes.
There is a new addition, can I say
Plus one.
Hmm.
extra again? The
Hmm.
next is AA. I mean, next is, so as soon as you are adding, what does the mean? I mean, what's the meaning of that? The meaning is I am adding a new thing, right? I mean, I'm getting a new substring, correct?
Yes.
Correct. So
Yes.
abhi tak A, AA, triple A, we have processed and we got 4 substrings. Now the important or the interesting part comes. We start from here. What is this character?
A.
So is A already available?
Yes.
That means we will not add now because A is already available, right? When you have done it for the first time only, you would have calculated that. So let's not calculate it. What's the second thing?
A. It's available.
So shall we add into our answer?
No.
Next character.
B. It's not there. Okay.
Now we will get +1, right? Because we got a
Hmm.
new substring now. So Sam, was this the one which you are telling?
Actually, like I'm telling, generating subsequences. Like when we get
Array, it's
substring. Sorry. When we get a substring, like adding this way, like checking if existing or not. I'll say adding and then increasing the count.
Okay, but
Mm.
fine. See, now you understood this process, right?
Yes, 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 yes.
Okay, so A B is हो गया. मनन process समझ में आ रहा है?
Yeah.
A. Up A is
Already
already
there.
there, so no addition. The second part is AB. So from A, can you see there is no B here? So
Okay.
if I have to add a new B, what's the meaning of this? The meaning is I got one additional.
Plus one.
Okay, so I guess the answer should be 7, right? We missed. Should be 7 or 6. Okay. The last substring is B. So can you see there is no B here?
Yes.
So answer should be 7.
Yeah, we got 7.
1, 2, 3, 4, 5, 6. Did we miss one substring here? Or
A अपन
अरे पूरा
भैया A पूरा
full
string भी
yeah,
एक का.
पूरा yeah. So now do you see the answer is 7 and we
Yes.
got 7, and now we don't have anything with set or map or whatever. We just went and we just checked. That's it. And this is a constant check, right? This is a constant check. So is the problem done?
Yeah.
Yes.
Okay. So let's quickly write it. Okay.
Hmm.
Public int count unique what substrings string s. Okay, so from where we will start? Obviously from
Node. root node.
Okay. Int n. So we'll just quickly अरे वही यार ठीक है. So we will go through each of the word. Okay. And parent node equals to root. Now for integer j equals to I, j less than n, j plus plus. First thing, what we need to check, if कर node dot child map अगर उसके पास नहीं है, then answer plus plus
Put.
कर node dot child map dot put s dot char j comma make sense.
Yes, correct.
कर node dot child map dot get
Current strategy.
and that's it. I mean,
Nice.
and you have all the distinct count ready with you. So shall we run and check?
Yes, bro.
Yeah, let's quickly run it. कहाँ है अपना?
Long में क्यों return answer करा?
Think why I returned in long. I mean, int also passes, but there can be many substrings, right? So that's the reason I wrote long. But I am just realizing now this is the constraints are this much, right? So n into n plus 1 by 2 will always be less than or equals to int range only. So doesn't matter. Okay. I mean, चलो ठीक है, int ही कर देते हैं खुशी के लिए.
नहीं
ठीक है. I listen, man. I listen. But if you ask this kind of questions, they won't give you bonus points.
shit man.
Try भी कर लिया ना. Try it out.
अगर input is high तो long देना क्या? Like
हाँ, जो भी इंटीजर पे पास नहीं हो रहा वो लॉन्ग लगा. चलो भाई, let's run it.
Same example.
Yeah. What's the string?
triple AB.
Nice.
आ गया?
Yeah.
चलो. Okay. So we have an answer. Okay. Now let's say I just modify the same question that okay, given a string, find number of good substrings. Now what do you mean by good substring? Good substring is each character will have some value in the sense good or bad. Okay, 0 means bad, 1 means good. So a substring is known to be good if there are only at most, I mean if there are at max k bad characters. Okay, so we have this word, right? A B. Now you will be given one 26 length ka array. 26 length because from A to Z. Okay, each character will have their value, whether it is good or it is bad. You have to count the number of unique substrings which are good. What do you mean by good? Good is a substring is a good if there are at max k bad letters.
Bad means 0 here.
Yes, correct.
Hmm.
So say Sam, we have k equals to 1. Okay, that means there can only be one bad character. Okay, and let's say A is also bad, B is also bad. So is A B a correct answer?
No.
No.
Is A a correct answer? I mean, is A a good substring?
Yes.
Yes,
Okay.
good substring because only one bad character. Okay. So, can you try to solve this problem from your own? I mean, this is the reference, same thing, but you need to do one more check. What is that one more check? That you need to maintain.
Okay.
Yeah, you need to maintain how many bad characters I have encountered till now.
Hmm.
Okay, so I believe you guys can do it. It's not hard. Okay.
Yeah.